All right, boys and girls, welcome to video lesson 4-fur part 2. Okay, our next type of factoring is called factoring by grouping, and we're going to do that when we have 4 terms, when we're going to factor 4 terms. So back in Algebra 1, you learned how to trinomial factor when we had 3 terms, right? Our beginning part of Chapter 4-4 this year, we were doing 2 terms when we were doing differences of cubes or differences of squares or sums and differences of cubes, but now we're going to factor by grouping when we have 4 and sometimes even more terms. But right now we're going to start with having factoring by grouping with 4 terms. The easiest one to do is when we're going to assume it's 2 and 2. So what I mean by that right now is I'm just going to put parentheses around my first 2 terms and around my second 2 terms like this. And I look at the first 2 terms and I say, is there a common factor that I can pull out of both of those terms? And yes, there is. I can pull out an x squared. When I factor out the x squared, I'm left with, you guys tell me, VG. That's very good. Very good in Spanish. VG is very, very good. I'm left with an x plus 2. And in the x plus 2 here, there's nothing that I can take out. But I'm just going to write this as 1 times x plus 2. So I now have 2 factors. The first factor is x squared times x plus 2. My second factor is 1 times x plus 2. Is there a common factor in both of these terms? Well, yes, there is. Of course there is. Yes, there is. There's an x plus 2. There's a common factor in x plus 2. So I'm going to pull both of those x plus 2's out. When I factor out the x plus 2, I'm left with x squared plus 1. So this is my final answer in factored form. It's right here. Let me get my pointer. It's right here. This is the factored form of my polynomial. It's x plus 2 times x squared plus 1. This is my multiplied form, my product form. Okay, if I were to FOIL this out, I'm going to end up with my original, and you can see that now, right now. What's x times x? That's x cubed. What's x times 1? That's plus x. What's 2 times x squared? That's 2x squared. And 2 times 1, of course, is 2. If I rearrange those terms, I'm actually going to get x to the third plus 2x squared plus x plus 2. Right there. Alrighty. Okay, so looking at this guy right here, I'm going to assume 2 and 2, so I'm going to group x squared minus 4x times xy minus 4y. In the first 2 terms, I can pull out an x, so I'm going to factor an x out. When I factor the x out, I'm left with x minus 4. Plus, what can I pull out of these guys? I can pull out a y. When I factor the y out, I'm left again with x minus 4. Okay, looking right now, I got 2 terms. The first term is right here. My second term is right here. Do I have a common factor? Do I have a common factor in both of those terms? Yes, I do. The common factor is right here, the x minus 4. So again, I'm going to pull the x minus 4 out of each of these. So when I do that, I get x minus 4. He's pulled out, and I'm left with an x plus y, x plus y. If I were to FOIL these back out, x times x is x squared. X times y is xy right there. Negative 4x right here. Negative 4 times y is negative 4y right there. And you can see that it works. Okay, you guys try this one right here. This is assumed 2 and 2, so go ahead and group this 2 and 2, and I shall be right back. Okay, when you did this, you should have found you had x squared minus 4 times 3 plus y. Let's show you how we got that. I grouped 2 and 2 from the first pair, the first set of two terms, I can pull out a 3. 3 is common to both x squared, 3x squared, and negative 12. When I pull the 3 out, I get x squared minus 4. Here I have a y in common to both of these terms, so I can pull the y out, and I'm left with x squared minus 4, and that's the whole point. You've got to have a common binomial factor. In this case, it's x squared minus 4. The x squared minus 4 comes out of both of these, so let me get my marker here just to remind you what I'm doing. I'm factoring out the x squared minus 4 from both of those. So I have an x squared minus 4, and I'm left with 3 plus y. There's my second factor. You think you're done, but we're actually not quite done yet. Look in here, I have x squared minus 4 times 3 plus y. The last step to factoring is to always check the primeness of each factor. Oh, well, x squared minus 4 is a difference of squares. So that can be factored as x plus 2 times x minus 2. X squared minus 4 is x squared minus 2 squared times, I still have my 3 plus y. And there is my final answer. Okay, watch out if the third term is negative. Watch out if the third term is negative. Sometimes weird things happen when our third term is negative. Well, that's not weird. I call it the little red light on the dashboard. The little red light on the dashboard. There's a problem when you're driving. It's a little red light that comes on in the dashboard. Don't ignore it. Just fix it. And I'll show you what that means. Okay, when I group this 2 and 2, when I group this 2 and 2, what I've done by building those parentheses is I'm distributing my negative. So that last sign, that fourth sign, so this used to be a negative x. Now, if we look here, it's a negative times a positive, which is still negative, so that's good. This negative times the positive becomes negative, but if you remember now, look at the black, my original problem, this was a plus 1. So all I'm going to do is I'm going to take my marker and change that positive sign right there to a negative sign. So if you have the third sign is negative, the rule is if the third term is negative, when you build your parentheses, change the fourth term, change the sign of the fourth term. So now when I distribute this negative, negative times negative is positive, and that's what I started with right from the beginning. So now that we've done that, go ahead and factor by grouping. I can factor out of the first two terms an x squared, and x squared is common to each of those, so x squared. I'm left with x minus 1 minus, there's nothing in common here, so I'm just going to write this as minus 1 times x minus 1. I have a common x minus 1. We could change colors. An x minus 1, a common binomial factor. Pull the x minus 1s out. When you pull the x minus 1s out, I'm left with x minus 1 times x squared minus 1. Whoop! Hold up 1 second. Hold up 1 second. We have a difference of squares. Ding, ding, ding. So this final factored form is going to look like x minus 1 times x squared minus 1, which of course is a difference of squares. X minus 1, x plus 1. And there is my final answer. X minus 1, x minus 1, x plus 1. Of course, if you want to, you could write that as x minus 1 quantity squared times x plus 1. Alrighty, you guys try this one. You got it. You guys try this one. I have ax plus bx minus ab minus b squared. Go ahead and factor that by grouping. Watch out, because our third term is negatory. Okay, when you do this one right here, we found we had our third term neg. So when I built my houses now, all I had to do was just change this negative to a positive when I built my house. Because now it has a negative times a positive is negative, and a negative times a positive is negative again, and that's my original problem. So this expression right here is equivalent to this one. So in the first setup, the first pair, I can factor out an x. There's an x in common. So it's x times a plus b minus, in this second pair of terms, I can factor out a b. So it's negative b times what's left, a plus b. I can now factor out the a plus b, so let me get my marker and just kind of draw that in for you. Factor out the a plus b. The a plus b comes out, and what's left is x minus b. So my factored form is a plus b times x minus b. How did you do? Okay, let's talk about the factor theorem. The factor theorem says if I divide a polynomial by a factor, in this case a binomial factor, if our answer comes out to be a quotient with a remainder of 0, then when 0 is a remainder, then x minus k, or whatever factor you had, is a factor of the original function, which also means by the remainder theorem that f of k will be 0. And that's what we call k a root or a solution. Roots or solutions we also call zeros. Okay? And f of k is 0, which means it's an x-intercept. And now we've gone full circle with all of those words for solution, 0, root, or intercept. Okay, let's find out whether x plus 5 is a factor of 3x to the 4th plus 15x to the 3rd minus x squared plus 25. It may or may not be. Let's see. We're going to see if it's a factor by dividing x plus 5 into this one. If the remainder comes out to be 0, then x plus 5 is a factor. If when we divide x plus 5 into this, we come out with a remainder, then we know x plus 5 is not a factor. So let's do this synthetically. Of course, we can do this synthetically. So I'm going to take my x plus 5. My q, of course, or my p, whatever we want to call it, is negative 5. I'm going to build my wall, and I'm going to write my coefficients of my dividend, 3, 15, neg 1. I have a 0 for the x and a 25. Okay, bring down my 3. Negative 5 times 3 is negative 15. That gives me a sum of 0. Negative 5 times 0 is 0. Negative 1 plus 0, of course, is neg 1. Neg 5 times neg 1 is pos 5. 0 plus 5 is 5. And negative 5 times 5 is negative 25. 25 plus negative 25, of course, is 0. Hey, hey, hey. I have a remainder of 0. So x minus 5 is a factor. Yes. So my product is x minus 5 times my quotient, which was now, this is my number term, x to the first, x to the second, x to the third, 3x to the third, plus 0x squared minus 1x plus 5. Of course, if I were to FOIL this thing times this thing, I would end up back here, but we're not going to do that. This is my product, my factored form of this polynomial. Okay, last one here now, last one. We'll do the same thing again. See, let's determine whether yes or no. Is x plus 3 a factor of this polynomial? We're going to do that by dividing synthetically this into that. So I'm going to do that right now. Get my marker. So I got x plus 3. That becomes neg 3. Build my wall. 1, 3, 0 for x squared, minus 1, minus 3. Right? Does everyone see that? Okay. To do this synthetically now, bring down my first term, which is 1. Negative 3 times 1 is neg 3. Neg 3 and 3 is 0. Neg 3 times 0 is 0. 0 plus 0 is 0. Neg 3 times 0 is 0. Bring neg 1 plus 0 is neg 1. And neg 3 times neg 1 is pos 3. Hey, hey, hey. Once again, I have a remainder of 0. So my quotient is going to be, now let's see, I have x plus 3 times, I have negative 1, 0x, 0x squared, and 1x to the third, x to the third minus 1. If you think we're done right now, okay, we'll see you tomorrow. Just kidding. we're not quite done because it says factor completely. Do you recognize x to the third minus 1 as something that is factorable? Very good. That is a difference of cubes. So my final answer now is going to be x plus 3, that's this guy, times x to the third minus 1 in factored form is going to be x minus 1 times, you guys are probably saying this out loud with me, times x squared plus x plus 1. Hey, folks, that's it. That's all she wrote. We'll see you mañana. Have a great night.